Our project is on the manufacturing process that go into making a Logitech M557 mouse. My name is Caroline, and my teammates are Elliot, Matthew, and Kevin. One of the main processes in making a mouse is injection molding, which starts with plastic beads being loaded into a hopper, then heated to a molten temperature and injected into a mold by the injection screw. Once the part solidifies, it's removed with injector pins. Here is the top and bottom shell of the mouse where you can see the injector pin marks as evidence of injection molding. There are even more injector pin marks circled in blue here on the internal part enclosure. The same goes for the scroll wheel cage and the optical lens. Next, the glide or skates, which are the feet of the mouse, are made out of PTFE, or more commonly known as Teflon. The Teflon sheets are made by a process called skiving, where the outside circumference of a solid billet is scraped or shaved off, and then die cut to shape.
For these wires, a copper rod was drawn through several dies of shrinking diameter until the desired gauge was reached. The wires are fed onto a spool, and the wire from this spool was then spun together with several other spools to create the final bare wire. This bare wire then passes through a crosshead die, in which a melted thermoplastic like PVC or polyethylene coats the outside of the wire as it passes through. The completed wire passes through a cool water bath before being wrapped onto another spool and packaged. Almost all springs are made in a two-step process. This spring is a torsion spring and was likely created using a specialized CNC machine, like that shown. After the form of the spring is made, it likely underwent a heat treatment. This heat treatment would have consisted of two steps and serves three functions. First, the heat treatment removes residual stresses within the spring. Second, hardening to increase its yield strength, and finally, tempering to ensure the spring's microstructure is sound.
Moving on to the PCB is constructed of numerous manufacturing processes. It starts with layers of fiberglass and epoxy that are pressed together in a process of lamination. Afterwards, the circuit pattern is drawn on using photolithography, which is essentially a thin copper sheet that's added, which uses light to mark where the copper paths should stay. After that, the board goes through chemical etching to remove extra copper, and CNC drilling to make small holes for components. After, a green solder mask and white silkscreen labels are added for protection, and finally, all the parts are placed and soldered using surface mount technology. The LED, on the other hand, starts off with a special process called epitaxy. Epitaxy is essentially when thin layered crystals are grown on top of one another in order to create a clear base for the LED. Afterwards, the process of doping occurs, which is adding tiny amounts of other materials in order to establish polarity within the device. The large crystal wafer is then cut into tiny chips through the process of dicing, and each chip is attached to a metal base using die bonding. Super thin gold wires are then added using wire bonding to connect the chips electrically and can reach it. Lastly, the LED is covered in clear epoxy in order to protect and help focus the light.
The screws that hold together the mouse are made of stainless steel and go through two manufacturing processes, cold heading and thread rolling. In cold heading, stainless steel wire is cut into small pieces, where these pieces are placed into a cold heading machine, where they are struck several times to form the head and the body, all done at room temperature. In thread rolling, the piece is then rolled between two hardened dies to form the thread profile. The last part of the mouse is the scroll wheel, which consists of three parts, the grip, the outer core, and the inner core. The inner core is made of ABS plastic and is manufactured through injection molding, where a mold is designed, which includes a hub mount, rims, and encoder slots. The thermoplastic is then melted and injected into the mold, cooled, then solidified. The outer core is also done through injection molding, but made of zinc alloy instead, where it is injected into a ring-shaped mold. Once it is done, it is removed, trimmed, and polished, then pressed or glued onto the plastic core. Finally, the grip is made of TPE, or thermoplastic elastomer, and is manufactured through overmolding. In overmolding, the soft rubber is injected onto the metal plastic core, bonding to it. With this, a protective ring that improves grip is made. Here are references, and thank you for watching.